Hello guys, welcome back to this physics video lesson number 6. In this video, we're going to start new chapter. The topic of the chapter is kinetic particle model of a matter. This is chapter 9 in your course books. And let's get started. So, why kinetic particle model? Why kinetic particle model? Well, this model, I will explain what's the meaning of this model. But in general, this model describes or explains why, three states of matter, like solid, liquid, and gas, and uh, uh, the model explains the properties, behavior, the change of state from solid to liquid, liquid to gas, like from gas to even solid, back to solid. So this model will explains why things behave as such. Like when we hit the solid, it melts. Why? So this particle model explains that, and we will learn about this. Um, we will use this model, this kinetic particle model, to explain change of state and behavior of gases, particularly gases, because it is how easy to. Well, I was telling that by using this model, we can easily explain the behavior of gases, and we use gases everywhere, isn't it? We breathe gas. We use like steam to generate electricity. Steam is a form of gas. So it's important how gases behave, and we use this model to explain the behavior. Right. So next chapter. Okay, next slide. Okay. Before we start, please take a time. Again, take a paper. Ponder. Take a paper, white blank paper. Just write three words: solid, liquid, and gas on a paper. And please write anything comes to mind, related words, vocabulary terms. Even you can scratch figures like here. So on. For example, solid. What comes in mind when you say solid? If comes a figure, just scratch a figure. And what's the relationship between solid, liquid, and gas? Like for example, when we heat the solid, when we increase the temperature, it melts and it turns to liquid. Things like that. So, what kind of words comes into your mind when you think about gas? Is it gas law, for example, ideal gas law? There's bonds. Is there bonds between gas molecules? Things like that. Okay. Okay. So we carry on. This is your job. You should pause here and do this activity. There is this interesting article in the book, course book. Well, it says there is a relationship. The scientists found a relationship between melting glaciers and volcano eruption. So you would say, what can be a relationship or correlation between volcano eruption and melting glaciers? Well, there is. You can read about it. So so basically, when the glacier melts, it reduces the pressure, which is stopping the volcano to erupt. When the glacier melts, there is a less pressure, reducing pressure. So now it is easy for volcanoes to erupt. So it opens up the ways, and when the glacier melts, it washes up with the earth, and it's easy for earth layer. It says here, easy for earth layer because of less pressure. The ground is more susceptible to landslide. So landslides, and it makes much more likely to volcano to erupt, and it happens. It's happening in Iceland, so it's interesting. So again, glacier melting is related to global warming, isn't it? When we hit the greenhouse gases, um, warms Earth's atmosphere and melts the glaciers, and then again glaciers lead to volcano eruptions. Okay, yeah, it's interesting correlation. You can read about it. Our main topic, yeah, before our main topic, on our Earth, on our beautiful Earth, the water. It's interesting, information, interesting fact. The water can be naturally in three states. Water can be naturally in three states, like gas, vapor, uh, oceans like a liquid, and ice or snow as a ice, as a solid, So water can be solid, a liquid, and gas naturally in our Earth, only on our Earth, right? Okay, now to the main topic, the kinetic particle model. What's the kinetic particle model? A kinetic particle, the kinetic means, as you remember from previous lessons, kinetic is related to motion. It means motion. Kinetic means or related to movement. Movement. So kinetic particle model says all the matter made of particles. Particles which are the tiny, tiny atoms, molecules, or ions, the smallest parts of matter. So the matter is made up of smallest parts, which particles, which are atoms, molecules, ions, and they are in constant motion. That's the main idea behind kinetic particle model. They are in constant motion. They are always moving, uh, and uh, and when we hit them, when we increase the temperature, the particles gain energy, and they want to move faster. They want to move faster, and then that's why the solids, when you heat them, they become a liquid, and when you heat the liquid, they turn into the gas because they gain more energy and move faster. The higher the temperature, the faster the particles move. Okay, here in this little animation, as the temperature increases from to 20 to 40, particles start moving, gaining energy, and move faster. Oh yeah, yeah. The yeah. So by the way, yes, yes. So yeah, continue. Yeah, if you have questions, I'll explain further. Right. So yeah, this was sorry. So we talked about this. Yeah, and another slide which explains the you know uh, uh, some vocabulary. Here are some terms. For example, solid. When we heat it, it melts the liquid. Liquid start if we start heating it. Liquid vaporizes, and the vaporized substances we call gas. Gas, we still continue heating gas. It becomes a plasma. We talked about it. Plasma. Do you remember plasma? But we're going to study only three state of matter: solid, liquid, gas, and their behavior, because they are much more common on Earth. Plasma is less common. It's becoming more common because of technology. Um, the fission, tokamak, as you remember, some instruments which analyze the atomic, or the what some of the instruments use plasma to analyzing, and some welding things. Yes, it's becoming a common. In general, we see is three three states of matter in general. So we're going to talk about only solids, liquids, and gas. All right, guys. So we said plasma. Plasma can be deionized. Uh, then it becomes a gas. Gas can be condensed. Then becomes cool down. When you cool the gas, liquefy it. Like have you maybe you heard about uh, LNG, liquefied natural gas? You cool it and put it under pressure, and then it becomes a liquid. Then you can carry more gas, so it becomes more dense. And then liquid frozen, can be frozen and turns to solid. And again, depending on the liquid type of liquid, usually it condenses. Then you can carry more liquid. All right. Right. Next is okay. So let's start with the solids. Solids. So the kinetic particle model again. So this model says that even though solids are uh, on your eyes, they are just stationary and not moving the materials. Uh, if you go to particle level, molecular level, atomic level, they are in constant movement. That's this model says. I mean, the kinetic particle model explains such. And yeah, because when you put into mathematical equation, that makes sense. Um, so this is a simple the animation, which is a spring model of solids. Solid atoms are uh, kept together because of bonds. From chemistry, you should recall what kind of bonds, covalent bonds, ionic bonds. They kept very close to each other, very strong bonds, very strong interactive forces. It's called molecular interactive forces, very strong bonds that attractive forces, keep the molecules together. But they're all constantly, fixed vibration. Goes, they have, you know, forward and backward fixed motion. Also, each molecules vibrate to throw and about fixed position. They have a regular and repeating pattern. It's called the crystals. That's they have a regular repeating pattern. They have well-defined shape, a definite shape, a definite shape, and volume. Clear, defined, very specific shape, volume they have. So this is the explanation of solids according to the KPM, kinetic particle model. Next is liquids. Hopefully, I'm not forgetting anything. The liquids. So, KPM, kinetic particle model, says that they are not the liquid molecules, liquid particles. They are not very close as much as solids. There is freedom that they can move, move around. Uh, uh, but they are not very apart as a gas. They are close to each other. Again, the interactive forces, they keep them together. Interactive forces. You should know about interactive forces, maybe from chemistry. Like for example, here is a water molecules. Water molecules, the interactive forces which keep motor molecules together is hydrogen bonding. Oxygen hydrogen bonding. It's called very simply hydrogen bonding. Here in the animation, as you can see, this hydrogen bonding, intermolecular forces, intermolecular forces keep them together, but they are still in constant movement. They are random motion. They move with a random motion throughout the container. They take the container's shape. Is that whatever container you put the liquid or the water, they will take that shape. That the hotter the liquid, the faster its molecules move. Okay. Mm, okay. Hopefully, I'm not forgetting anything. There are other, it could be details, but these are the main details. And the next one is gas. It says gases. So again, our model, kinetic particle model, says that molecules in gas much further apart. They are moving in a straight line motion. They are moving in straight line motion. It's not random, not random. They are moving straight line motion, but when hit each other, they can change the direction at the random, depending on how they hit each other or how they hit the wall of container or vessel. Depending on how they hit the wall, they move straight line. So they can be compressed. They can be compressed and reduce the pressure. Sorry, increase the pressure. Or reduce the pressure. The compressed and increase the pressure. The, the the molecules dash around. Molecules, fly or run around very fast, very fast. Uh, say like an average about 500 meters per second, and that's why you can smell if somebody cooking very delicious food. You can smell this from far away, maybe in quicker time but still there is the motion, molecules bumping each other, but it reaches you, you know, smell reaches fast. Anyways, I don't want to distract you. So this is again animation of gas makes you it gives you some idea. You know, they're further apart each other. They move fast. Their motion is straight line. Their motion is straight line, and we can assume we will learn in the next video. There is another model which is a kinetic molecular model. Kinetic molecular model, if I'm not mistaken. Uh, this this models this model actually this model assumes that there is no interaction or very weak interaction in the gas case. Intermolecular force. They are moving around the gas molecules, and there is no or very weak intermolecular forces or attraction forces between gases. They don't attract each other unless they are, polar, very strong polar molecule. Um, yeah, it assumes that there is no attractive forces, attractive and repulsive forces, intermolecular forces among gas molecules. Okay, hopefully I'm running out of. So you can read through this. I'm sorry I put many descriptions in these slides, but the idea is I wanted to explain is that when we cool down or take away the energy from the gas, it becomes a liquid, and further cooling will lead to the solid. And vice versa, I can increase the energy, and then I can melt the solid into liquid, and liquid can vaporize into the gas, and there is other way around again, the condensation and freezing. Okay. I'm just checking. Did I miss any words? I think so far. So we talked about the model which explains why things as such. Here, okay, the motion of particles we talked about. They're all in motion. All particles are in motion. Even in solids, they are in motion, um, because they have energy, because there is intermolecular forces. Some, the protons of this atom, they repel each other. They don't like each other. They repel each other because they kind of positive charge. Uh, there is a but there is around them electrons. So proton is attracted to the negative charge, which is electrons. So this is they pull each other. So that's why there is a motion, constant motion going on. Okay, there is uh, of course we don't cannot observe with our bare eyes, molecules, how molecules move, but there is observations we can do, experiments, isn't it? And this experiment is called a smoke model. Here is the big circle in the middle. This is a smoke particle PM 2.5. Maybe you heard about it. Particulate matter 2.5 diameter in across, smoke particle, and we can put smoke in a container under the light. This is not vacuum, this is air here already. We just put smoke here, and we can observe the motion of smoke particle. Smoke particles, as I said, this is PM 2.5 or PM 10. Compared to air molecules, oxygen, nitrogen, smoke particles is very big. They are very big, so it can be observed under the microscope. It can be observed under the microscope. So this is microscope objectives. Can be observed the smoke particles. So and here in this slide, this shows the yellow is smoke particle. Shows Brownian motion. Brownian motion. What's Brownian motion? Brownian motion is a random motion of small particles suspended in a liquid or gas caused by molecular bombardment. So air molecules, they are moving, straight line, but they are bombarding the bigger molecules like smoke molecules here, smoke particle here, which is PM 2.5 or PM 10. And because of bombardment of air molecules, the smoke particles moves uh, randomly, and this is called Brownian motion. Brownian motion. Okay, so yeah, that's all today I wanted to talk about, and our time is already up. By the way, the smoke particle is not healthy. It's from car, motorbike exhausts, or power plants. PM 2.5. Maybe you heard about PM 10. They are 2.5 micrometer in diameter. The small particles, which can be harmful um, for the the breathing, um, lungs. Even they can go to the blood vessel and damage the blood vessel walls. Inflammation. There are research going on, but it is more likely that smoke particles, which is PM 2.5, PM 10, they are harmful to the health. Anyways, again, I distracted from the main topic. So please, this is a comprehension check. Please have a look. Take your time, pause it, do it, and we have a homework, which I will upload it. I'll upload it on Google Drive, Google Classroom Drive, and please do your homework. Okay. Take care. Stay happy. Stay healthy. Be happy. I'll see you on the next videos. Bye.